Colleagues, welcome back to the office. We're going to get started with our presentation here just in a moment, but before we do, I have a couple of brief announcements to share with you. First, if you're watching our course live, please note that we'll confirm your engagement through polling questions that you can respond to. Polling questions will occur about every 12 to 20 minutes, and please keep an eye out for them because they might not be announced. If you're watching after the fact, it's a self-study course. You will confirm your participation and engagement with our course today through a brief quiz that you'll complete on cpetoday.com after watching or listening to our presentation today. Your completion certificate will be sent to you by email. As long as you respond to 75% of the polling questions, if you're watching live, you will receive full credit for today's course. If you're watching after the fact as a self-study course, please note your certificate will be available to you immediately after passing the course quiz. We'd love to know what you think of our content and of our presentation today. If you wouldn't mind completing our course evaluation to provide your thoughts and feedback, we'd love to hear from you. Your feedback is used to help produce better and more insightful courses for you to consume in the future. If you have any questions, we'd love to hear from you. If you're watching live, feel free to use the chat dialog box to ask your questions to the presenter. And if you're watching after the fact, you can send us an email at support@cpetoday.com and we'll follow up with you as quickly as we possibly can. As a reminder, the CPE Today podcast is available as a joint effort between CPE Today and K2. Twice a week, we're bringing you the latest and greatest in technology, accounting, business knowledge, and more. You can watch for free on cpetoday.com, YouTube, or Facebook. If you can't make the live presentation, you can subscribe on Apple Podcasts, Spotify, Google Play, and listen to the show on your own time. All of our podcasts are eligible for CPE credit. After watching or listening, you just head over to cpetoday.com. You complete a short 5-question quiz, and you'll earn a credit for watching or listening. Now, if you've never tried one of our classes before, how about you try one on us risk-free? You can use coupon code ONEFREEPODCAST at checkout to make any podcast course of your choosing 100% free. We're going to get started here with our presentation. And again, thank you so much for being here. We hope you enjoy the show. Okay. Welcome, everybody. This is Excel Essentials for Staff Accountants. My name is Steve Yoss. Again, it is a pleasure being with you in our class. Today's class is going to be looking at everything I think you need to know as a staff accountant to be effective and useful and productive inside of your organization. Excel is one of those things. It is the Swiss Army knife of business. It's one of my favorite metaphors to use when discussing this application because it really can be and serve so many different incredible purposes for your organization. Everything from producing financial statements and doing detailed analysis to just being something for scratch work and figuring out and just doing a quick and dirty, analysis to figure out the, profitability or figuring out what inventory, you should purchase or carry in the coming year and more. And it's a tool that many of us already have some experience and familiarity with, but rarely are we specifically trained on how to use this tool effectively. And so we kind of, just learn on the job, and most of us pick up things from other people. But we don't ever kind of learn what those essentials might be, and what we could essentially do inside of this application at a ground level to really kind of be effective and powerful in this application. And what this class is aimed at is really kind of aimed at providing that deep level of foundational skill within the context of using Excel to give you the insight and the skills necessary to not only just be able to use this application, but to really use it effectively. I want to teach formulas in the context of tables. Tables, if you're not familiar with them, they are a container for information inside of your workbook. And now you might look at an Excel workbook and you say, Steve, well, there are, rows and columns. I really feel like that's a table. And you're correct. There are rows and columns, but a table is a purposeful thing that you add to an Excel workbook. And they make virtually every operation inside of Excel better, more efficient, faster, and easier to use. I use them constantly. They're probably the thing I do the most inside of Excel. They auto-replicate formulas. They make styling efficient. They are wonderful for precursor functionality for things like pivot tables or charts, graphs, and more. And in the context of formula writing, the structured references that tables provide
make it a no-brainer to use. And so we'll probably talk about tables first and then get into some formula fundamentals that I think are useful for you to know, including alternatives to formulas too. Sometimes formulas might not be the best option. And so I'll kind of show you some of the other things that you could do that can achieve the same effect as a formula, but might be a little bit different with respect to how you go about doing it. Okay, now from there, we're also going to talk about some accounting-centric formulas. In this particular chapter, we'll talk about, for example, the difference between subtotal and sum, doing conditional comparison using SUMIFs, super useful tool where you can, sum or average or find the min or max based off of multiple criteria. We'll talk a little bit about text to columns, and I'm also going to, in this chapter 4, introduce a tool that's not included in your book here, but I think is really useful for you to know, called Power Query. Power Query, if you've never heard of it before, is a tool that allows you to create repeatable, refreshable reports. There's a mantra that I personally live by with Excel: write once, refresh many. If it's a workbook that I'm going to do month in, month out, I really want to make it so that I can make this thing as easily updatable as we can. And Power Query is that tool that allows it. It's a ETL tool, extract, transform, and load, allowing us to extract and transform data from virtually anywhere that is structured, whether it be another Excel workbook, a database, the web, API from an application, and more. Alrighty, we'll talk about some different lookup formulas, VLOOKUP, HLOOKUP, index and match as well. Alrighty. Now, before we get going, I got a couple of housekeeping announcements, and then we are going to go ahead and get started here. Again, my name is Steve Yoss. I am an instructor and presenter with K2. I've been an instructor with K2 now for many years. Many of you I've had in classes before, and if you're a returning student, thank you so much for coming. It's always a pleasure to have you in our classes. And if you're a new student, thank you. I appreciate you coming to check me out and coming to check out what I have to teach here. In my life, my experience is split right down the middle. Half my life is spent writing and teaching and thinking about technology. I write anywhere from about 20 to 50 courses per year on Excel, Power BI, databases, security, fraud, accounting, audit, you name it. And the other half of my life is spent doing software development in my business, Devmatics. My business, we build all different types of applications with our American-based engineering team. We build mobile apps. We build integrations between different tools. We build custom databases and more. If anybody has any questions on tech, by all means, please consider me a resource. You can always reach out, and I'd be happy to answer any questions, or at least at the very minimum, try to point you in the right direction. All right, folks, without further ado, let's go ahead and get into it. And the rest of our class today will be entirely inside of Excel. So we're going to go ahead and now take a look at some formula options with respect to our workbooks, as well as some non-formula options that we might want to consider looking at as well. So we discussed tables and how useful and effective that they are. Let's talk about formulas now and how they can be used in conjunction with Excel, as well as alternatives to formulas as well. Let's go ahead and take a look at SUMIFs. Now, I already did one example of SUMIFs. Let's do a couple more. Okay, now we've had SUMIF for many, many years. Average if, max if. Now, these were single criteria logical expressions, meaning they would go and sum one thing, average one thing. Okay, we now have SUMIFs, average ifs, min ifs, all of the ifs. And the difference is here, it's IFs, meaning it is as many criteria as we want. So what this allows us to be able to do here is it allows us to be able to go and have a range of data, as we have here. We have 37 rows, and we can now conditionally add up our sales of, let's say, lotions in the Northeast, or our Midwest and what we sell for masks, so on and so forth. Okay. And we can give it additional criteria, like 2 or 3 different things to look at. So when condition 1, condition 2, and condition 3 match, go and add them up, average them up, find the min, find the max, or whatever else we'd like it to be. Okay. Pretty useful with respect to what we can do with this. And so let's go ahead and explore this a little bit and write an example here doing our SUMIFs off of multiple criteria.
Okay. So I wanted to sum up our sales where Northeast and lotions come together, South and creams come together, so on and so forth. So we're going to do equals SUMIFs. Okay. And then our sum range, in this case, we would specify it to be where the math occurs. In this case, I'm going to be a little bit lazy here. I'm going to specify the whole column. Okay, I'm going to show you here in a minute how you could specify this using tables, which makes it even better. But bear with me. I'm going to go ahead and say column D. Okay, and then our criteria range 1, criteria 1. So in this case, our criteria range, let's go ahead and look at our Northeast first. So that's going to be column B. And then we're going to specify this, and we're going to say F8 is where that is. And so we're evaluating column B to the value in F8. Okay, now I can just end this right here and it'll get me a number. I don't have to have 2, 3, 4 criteria. I can just have 1. So everything SUMIFs can do can be, everything that SUMIF can do can be done in SUMIF. So you don't have to have multiple criteria to make this work. But that's really kind of what's intended. But what we can do is now we can append this and we can add criteria to. So in this case, let's look at our product line. That's going to be in column C here. And we're going to point this to row and column G7. And there you go. So for our Northeast, and it just grabs this data. Now, as much as I like this, if I start dragging this cell over here, well, unless I make those cell values absolute, you're going to start to see those values kind of shift. Okay. And so what we have to do here is we have to come in and we have to make this absolute in order for this to be able to work. And so we tell don't move F8. And in this case, don't move off row 7. Okay, we have a couple of different methods of creating our formula references here. The $, just as a reminder, makes a position fixed. So what we're saying here, no matter how I move this cell, don't move column D, don't move column B. It will stay in fixed position. Now we can also have what are called mixed. You'll see over here F8 and G7. I have a $sign in front of F and I have a $sign in front of 7. That means as I move this around, either keep the fixed column or the fixed row, just depending on my specific needs and wants and what I'm trying to do here for my calculation. Alrighty, so in doing so, now if we drag this across and drag this down, we're getting that correct reference, okay? Now, we can also do this inside of a table, and for lots of reasons is going to make this a lot simpler. Let me show you how we would do this inside of a table. First things first, we're going to want to know the table name. In this particular case, the table name is sales, okay? Watch this. Now, we're still going to reference out to our criteria 1 and criteria 2 because those are not inside of our table, but we can tell it to look at a specific column when it's doing its reference. So in this case, we'll do equal SUMIFs. Okay, our sum range here is going to be our sales table, specifically our amount column. So we're telling it just that. Okay, criteria range 1 is going to be the region. So we're going to say the sales table, the region column, and we're going to go ahead and point it over here to F8. And likewise, we're going to go ahead and say our sales table and then our product line, and we'll point this over here to G7. Okay, that does the exact same thing. Now, the point of this is with respect to tables, look at the auditability of this. Instead of having to remember where every column is and what every column does, what we could do here is we could see, okay, he's summing the sales amount column. Okay, that makes sense. Okay, then we're doing our region and we're looking at the region to cell F8 and comparing it. Okay, that's right adjacent. That works. I'll point out we could also substitute this with the defined name if we wanted to as well. Okay, and then we got over here our sales product line. That makes sense, and we're comparing it to G7. And so that makes it much simpler and easier to be able to do. Okay, now the one drawback with respect to tables in this specific arrangement, if I drag this across, I have that same issue. It's not going to keep the position of these things fixed. And unfortunately, there's no easy way of fixing this. But what you can do is you can tell it to look at a range and then it'll keep that fixed range. And so this looks stupid, but bear with me here. I would need to do something like this if I wanted to keep the fixed position of a table. So in this case, I would tell it to sum sales amount to amount, and by specifying a beginning column and an ending column, and I would come over here, same thing. We would do colon sales region like this. Same thing with our product line like that. Okay, and then we'd still have to make these things relatives or absolute. So we'd say F8 here, and we'd make this absolute with a $sign in front of the 7 for G7 and in front of F for F8. Well, now we've done this through tabular reference, and we can now drag this across. I don't know why that's doing that, but that's how we would do it. Now, what we can also do that I think is probably easier, instead of dragging this across, we can just go ahead and copy and paste the formula. And if we just copy and paste the formula like this, okay, then we can go ahead and we can move this accordingly. Okay, and once you've moved it across, one of the nice things is you can copy it down and it should move fine at that point. But for whatever reason, this just tends to be a one of the kind of hiccups here. Let's move you back over here. Okay, and that should copy down now correctly. Yes, okay. It's just one of the hiccups here with respect to tables. You be conscious of it and you just know about it and you can work yourself around. Okay, so that is going to be your SUMIFs. Now, you can also do the same thing with respect to dates. Okay. So in this example, we've got our sales, we've got our revenue, we've got our beginning date, we've got our ending date here, and we want to sum between these particular things. Well, we can also do a comparison here over time, okay? So now this one's a little complicated to do. And what we've got here is we've got SUMIFs, and we're telling it exactly the sales table and the revenue column. And then we're telling it an actual inequality operator, which I find to be quite interesting. And so we could say here, sales date, okay, where it's greater than or equal to F3, sales date less than or equal to F4. And so let me show you how you write this example here. And it's, again, kind of interesting to see this exact formula kind of come together. But we're actually specifying an inequality, and then we're using that inequality in our lookup. Or not our, well, I guess it is kind of a lookup in a way. All right, so we're going to come over here and we're going to have our date, making sure this is a valid date, not a text date. And we'll do equals SUMIFs. Okay, and our sum range here is going to be our sales table, our revenue column. Boom. Okay, and then we wanted to do, again, this adding up if it's after, on or after the beginning date or before or on the end date. And so we're going to say, look at the date column. So we're going to go to the sales table. Date, and again, square brackets always indicate tables, always. Okay, so anytime you see a square bracket, you know it's going back ultimately to a table here. And then what we're going to go ahead and say here is for the criteria, okay, double quote, and we're going to say greater than or equal to, and that's by this symbol and the equal sign. So that's greater than or equal to. Then we're actually going to concatenate, and we're going to point it over here to cell F3. And let's just end that for a moment. Okay, so if we add up just the sales from January 1st after that date, okay, how many do we have in here? Well, we have 18,000 rows. Well, that's just the sales after that date. Well, we can add a second criteria here, and we can say before a specific date as well, before that end date. And so we'll specify a second criteria. And we're going to go ahead and say our sales table, go look at our date column. Okay, and the exact same thing before. We're going to go ahead and say where it is less than or equal to. And then we're going to do an ampersand here to concatenate, and we're going to go ahead and specify our end date. And then that gets you that specific criteria. Okay. Whew, that's a lot, right? Now, let me show you one other thing that you could do to maybe make this a little bit, I wouldn't say easier, but fault proof. And that would be to use something called data validation. Okay. Ideally, you've got this set up and you've written a formula in here that could be, in this case, pretty complicated. Is expecting a specific format. One thing that you can do to ensure that you get the same consistent format with respect to your data is to utilize data validation. What data validation is going to do is it's going to look at a cell, and it's going to see if the value in that cell matches the specified criteria for what that cell can take. Like, you can specify a cell that can only take a date, it can only take a time, it can only take an integer, and it can only take a decimal, or it can only be from a predefined list, and anything that doesn't match that criteria gets kicked out. Now, in this case, I don't want any data before January 1st, 2019. And let me think about our max data. Let's just go ahead and flip this to, I don't want anything after maybe, in this case, December 31st, 2023. Well, what I can do is I can put some data validation on this cell, and it's going to prevent somebody from not supplying a date, so I'm not putting in, alpha characters here. And I can also specify that that date has to be within a specified range. Okay. Now, to add data validation, really simple. What you're going to do is you're going to come over here to your data ribbon, and under your data tools, you're going to see this option here called data validation. If you select this option, this is going to be where you can narrow the focus of a particular cell. Now, by default inside of Excel, everything is set to any value, meaning a cell can contain alpha, it can contain numeric, it can contain a date, it can contain a time, it can contain whatever you want it to be. Now, what we can choose to do is we can choose to say, hey, you know what, this is actually going to contain a date, and then we could specify a particular date. We could, for example, write a little formula over here. So we could say equals max, and we could go ahead and write a formula that would look at our values here. Actually, let's move that over here to our end date, and let's change our max formula over here to min and click OK. The benefit of this, if I try to put in a data over here like 2018, it's going to stop you because there's nothing in there. It will never let you specify a cell value greater than or smaller than whatever values are in this specific data set. So if we change this to 19, no problems, it takes it. And so with that data validation tool here, what we've done is we've created a really, really nice way. We've created a really nice way to kind of limit the focus of what that cell can provide. And we're not going to be able to put something in there that doesn't match what we want back. Any sort of workbook that you're going to be giving out to other people that you want them to work with, you're doing yourself a service by limiting, especially any input cells, to only allowing whatever value you want. And that's going to help themselves from not having issues or errors with their formulas. And so if you want to limit a cell to a specific number, a range, a date, a time, a list, you can have a drop-down list of selected values. This is going to be where you're going to do it. Okay. And you're going to specify this here. You can also specify a message. An input message. So you could say, for example, like you must pick a date in the future or whatever you'd like. And you can also specify an error message too. So if somebody provides a value that they shouldn't have provided, well, guess what? It will alert them on what their errors are. Okay. I use this feature all the time, especially for anything that is going to be used by my staff, and again, not everybody has the same level of expertise that I have with respect to Excel. Okay. And I can go ahead and specify that value and what the conditions of that value might be. So great. I personally think with respect to budgets, I would tell you that with respect to any sort of calculation or anything where you're going to need to get a specified value from somebody, if you limit the criteria with those data validation rules, it's going to help ensure the value that you're getting back is the data that you wanted. Garbage in, garbage out. This helps prevent that garbage from coming in. All right, so SUMIFs works the exact same way as average ifs, which works the exact same way as min ifs, max ifs, and more. Okay, so they all work the same. You have a criteria, and then you have whatever range you choose to do your data calculations on. Alrighty, so for our next example here, let's go ahead and talk about text to columns. And text to columns is going to be located over here under the data ribbon. Under your data tools, you'll see text to columns listed here. And what this does is it parses data. Okay, so we've already talked about two very concrete examples. I gave you the flash fill, which I could, for example, give it a demonstration. Like over here, we can go ahead and say Atlanta. Okay, Augusta, and you'll see it continues that pattern. Okay, and we also talked about how we could use text functions. In this particular case, we could go and find our comma here. Okay, and then we know with the text functions, we can go ahead and point it over here, and we'll tell it to not include the comma, so we'll do a -1, and we can go ahead and we can grab that data out that way. Okay, here's the third method for splitting this apart. You might think, why the heck would I ever want more than one method to split data apart? Fair enough question. I would answer you, well, why do you have multiple screwdrivers in your tool chest? Why do you have multiple pairs of pliers? Why do you have, why do I have like 5 different types of oil in my house? I've got oil for my off-road car. I've got oil for my truck, diesel. I've got oil for my boat. Different tools for different jobs, man. You pick the right tool for the job depending on what you're doing. So here's another tool. It's text to columns. Now, text to columns in a lot of ways I've personally replaced with Power Query. I personally think Power Query does a better job. But you still have a very good need for text to columns as well, and you should at least know that this exists. This is going to be over here under the data ribbon. You'll see text to columns listed here on the right. And this is also a discrete thing. So just like conditional formatting, you're going to need to select the cells you'd like it to apply to, and then you go ahead and you hit that text to column. Okay. You can only select one column at a time though. Okay. If you try to select 2 columns at a time, it's going to be like, hey, I don't know what you're talking about here. Only one at a time. So come on over here, quick tip, Control-Shift down arrow selects the whole thing. And we're going to come over here to our data tools, and we're going to go ahead and select that text to columns. Now, text to columns can work one of 2 ways, delimited and fixed width. Fixed width means everything you're working with is the same size. Like a social security number is a great example. 3 digits, a dash, 2 digits, a dash, 4 digits. Always the same. Doesn't matter if you have social security in New York or you have social security number from California. They're always in the same order. So you could use fixed width if you wanted to break it into 3-digit, 2-digit, 4-digit. However, in practice, you're probably almost always going to choose delimited. And with this delimited, what you can choose to do is you can choose to break it into separate cells depending on the delimiter. And ideally, you'll have the same consistent delimiter across the different data that you're working with. And you'll know that ahead of time. I can look at this data and I can actually see there's 2 different delimiters. There's a comma and a space. In this particular case, I could ignore the space. But what I would choose for my delimiter here is instead of tab, that space. And when I click this, you can see here, or sorry, not space, comma. Actually, space is a good example. I'll point out, if you use certain things like space here, we can see Baton Rouge. It can't tell the difference. So if you chose like a space and you got spaces in between things, it's going to cause you issues. In our case, we can actually ignore the space and we can choose just the comma. Okay. And what it's going to do is that when it sees that comma, it's going to go ahead and move that value over to that next place. Okay. So we're going to see it split across this way. Okay, simple thing, pretty useful for you to do. I still use this. The big issue with respect to text to columns, I would say, is the fact that you have to run it every time. And increasingly, I'm using Power Query to dynamically fetch my data. And Power Query can absolutely do what we do here with text to columns. But as that data gets improved and as new data gets edited, updated, and deleted, well, it is going to go ahead and continue that pattern for me, and it's going to go ahead and continue that. So let's do that one more time. I'm going to paste values here, just so you can see the original data next to the modified data. Okay, we'll do that data, text to columns, delimited by that comma, and here you go. this is put into one nice order. Now, text to column says other stuff too besides this that you should know. And one such thing that it does, which is kind of nice, is if you have data in the wrong format. God, let me find it. Let me see if I can find an example. Okay, give me a second here. I want to show you something. All right, let me just take this into a new workbook. I think that was causing me issues. Okay. It's not showing me the issues that I want. Okay, I'm going to have to explain this because I don't have time to set up a demonstration file for it. If you had a bunch of data stored as text, okay, and you want to not store it as text, actually, let me see. Let me try one more thing here. Okay, like dates are a good example of this. Okay. Okay, you see this over here, this little green flag. Okay, if we hover over this, you'll actually see that this is a date that's not being stored correctly, and it's actually a date being stored as text. One of the other useful things that you can do if you have a bunch of text in your document and you want to turn it back, if you want to turn it back into a value instead of text columns can also do this as well. We can select this data, come on over here to our data ribbon. We can go ahead and select text to columns. And we actually aren't going to parse this at all. We're going to leave it exactly the way it is. But we're actually going to choose it over here under our column data format. And if we choose this to general as an example here, it's going to convert those back into whatever standard format it should be. And if it's a date specific, one of the things that we can also do with this is that we could specify the order. So if it's month, date, year like this, it'll also convert that back into that date. And if we see over here, in fact, it is. Okay, question popped up. Why does text to column shift the data down one row? I'm not seeing that. When I select just this cell here and I'm selecting A2 to A17 and I run that text to columns here, and I do that comma, I'm not seeing this shift at all. I'm seeing it stay in the exact order. If you could maybe provide a little bit more insight in what you're seeing there, I'd be happy to try to answer that for you. All right, let's continue to move on here, and let's go take a look at our lookups. Okay, and I'm going to be conscious of, and I think this might have been what this person popped up, just be conscious of you're picking your data and not your headers. Okay, that would probably be a pretty good thing to consider. Text to columns has no concept of tables. It has no concept of header rows either. So you just do it on the actual data itself. But that might have been the reason why. Okay, let's go ahead and do a example here, looking up at some lookups, and I'm going to go ahead and share another example here. And I want to share with you a couple of different examples of how you can do some lookups. All right, so we have a lookup specific example that I'd like to use here. And I've got the three main ones I think you need to use and know. And we're going to use these as our example here. Okay, now I'm going to preface this by saying in today's world, you use XLOOKUP. Okay, there's only one reason not to use XLOOKUP, and it is actually two reasons. You don't have it because you're using an old version of Excel, or you have a new version of Excel, but you have team members who have not upgraded and they still need access to your workbooks because XLOOKUP is a 365 subscriber only feature, and it is also only a feature in the latest versions of Excel. I believe they added it in 2019. So it's been around for a while, but VLOOKUP's been around for like 30 years to put it into perspective. Okay, but XLOOKUP is by far my favorite, and I'll show you why. And then we've also got index and match and VLOOKUP. These are going to be the 3 lookup formulas you really just need to know. Everybody should know how to do all 3 of these. In practice, I probably use index and match more than any of the other 3. XLOOKUP's my favorite, but I work with so many people. I need 100% cross compatibility in my workbooks when I'm sending somebody something. So I use index and match a lot, but if you can, use XLOOKUP, because overall that is definitely going to be your best option. All right, let's go ahead and do some examples of this. So first off, we're going to take a look at VLOOKUP, and I'm going to use VLOOKUP in the context of tables, okay? Now, VLOOKUP has 4 operators that you need to know. What you're looking up, what you're looking up to, what you'd like back, and whether or not to get a exact or an approximate match. The syntax formula for this is really, really simple, okay? And so let's specifically go look for Ronnie here. Let's go look for his specific record. And often with the lookup, you have a value, and you want to go look up that value somewhere else, and then you want to get some data about that value. Very rarely in a database, or you can have all the data that you need in one central nice place. Very rarely is all your data going to be tied up in a nice bow. Often what you're going to end up when you're working with data from the web, from a database, from an API, is that you're going to get a key of some sort. In this case, it might be a customer ID, it could be an invoice number, it could be a check number, it could be a transaction ID, it could be something. But in this particular case, maybe I'm looking at my orders here, and I can see that order 123 was ordered by customer 1010. And in my database table, I'm only going to see customer 1010. It'll say customer ID equals 1010. That's completely normal. In databases, we have this principle called single responsibility, meaning something should only be responsible for one thing at a time. Okay, meaning your customer table doesn't hold order information, doesn't hold payroll information, it holds customer data and customer data alone. And even beyond that, it can be a lot more fragmented than that even. Okay, and then you also have this other principle called don't repeat yourself. Okay, meaning I don't need to store customer data in 2 places in my database. I only want to store it in 1 place in my database. And if I need to go look up customer information, I go back and I look it up to the customer table. But I don't want to repeat myself. I don't want to have that data stored in more places if it's not necessary. Not only is that bad form because of updates, but it also takes too much space. Okay. So in this case, we've got employee, customer, whatever here, 1010, and that's the only number I have. And I want to be able to go and find some information about that particular person. All right. So what we're going to go ahead and do here is we're going to go ahead and look up 1010 using a VLOOKUP first. So what we're going to do here is first want to know the name of the table. So this name of the table is going to be clients 43. Okay. And then we're going to want to know the index of this, meaning what column does what. Okay. And unfortunately with index or with VLOOKUP, we need to know the order of the columns. Okay. And in this case, if I wanted to get first name, it would be column number 2. Last name would be column number 3. Email would be column number 4, so on and so forth. VLOOKUP, in a lot of ways, should be avoided whenever possible for a couple major reasons. First big reason, they're super slow. Okay, if you're going to have performance issues in your workbook, it's going to be because that workbook has a ton of lookups, and a ton of lookups absolutely going to make your workbook slow. Second big thing, whatever your ID is has to be the leftmost column of the array. So it has to be the furthest column to the left. You can only look up in a VLOOKUP to the right of what your index is. And frankly, that's not realistic given modern anything. I mean, your index, your column you're looking at might be the 10th column, might be the 300th column, who knows? But it has to be the leftmost column of the array. And then you also have to know the index number of whatever you're looking up. So you have to remember what's column 1, 2, 3, 4, so on and so forth. So if we're doing ID 1010 here, we want to look up first name. It would look something like this using tables. So we do equals VLOOKUP. All right, I want to look up B3. Okay, our table array here would be clients 43. Our index would be the first name, which would be column 2. If we want an exact match, we'd go ahead and say false, and that gets us Ronnie. Okay. Now, if you want to do bonus points here, you could create a defined name for this. So we can say look up value as an example, and we could actually substitute the cellular reference for the defined name. So we could do for our last name equals VLOOKUP So go look up value, okay, which is that cell over here. Go look it up to the client's 43 table. Get me the third column, which is going to be our last name. And I can actually omit that true and false. It's not really needed for this exact example here. Now, isn't that nice with respect to your auditability? I can say, oh, I'm looking up the lookup value to the client's 43 table and getting the third column over. Okay, that's all you have to do. Okay, for our title, we'll do the same thing. We'll do equals VLOOKUP. Go look up the lookup value. Go look it up to the client's 43 table. And go and grab me the... Oh, sorry, I can't do that. I'll do that in a minute here. And go grab me the title, which would be the, was that 1, 2, 3, fourth column over. Okay. Oh, that's the email. Okay, go get me the 5th column. There you go, our technical writer. VLOOKUP is probably the easiest of the bunch, right? All right, let's look at another one here. This is going to be index and match. Okay, index and match is actually two different functions. There's match and then there's index. And confusingly, index does what I think match should do and match does what index does, okay? What match does is match will go, let's go highlight Ronnie over here again. Okay, match will go and look up a specified value and then return to you the row number of where that value is located. So in this case, if we're looking up Ronnie here, it's going to come down and it's going to figure out where Ronnie is located, and it will return back, in this case, 2, which is the row number of Ronnie. Okay. Now you might look at this and you might say, whoa, 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 Steve, how is it row number 2? This is clearly row number 8. It's relative to the array. Okay. So in this particular case, it's looking at the table. This table is clients 434. And we're looking this up and we're looking up down here and we're looking for Ronnie. Well, that's row 2 of table 434. And so it'll actually return back 2. Okay. Now index will go to a specific row number and then we'll return back whatever column we tell it. So I'll tell it to go to column 2 here and return back the first name, the last name, or whatever else. And index and match is how we will do both of these simultaneously. Okay. So let's go ahead and write this. We'll do equals match. We'll tell it to go look up B3 here, and we're going to tell it to go look up the client's 434 table. Now here's where the kicker is, and this is where you're going to start to see the overlap with index and match with XLOOKUP. You specify not only the table, but the column that you want it to do the lookup in. And so I can go over here and I can say, go look this up to the ID column, and it will only look up there. That column could be the first column, the 10th column, the 50th column. It doesn't matter because I'm specifying exactly where that data should be. Now the next is going to be what type of match we want. Now with index and match, or with VLOOKUP, we could only really get the first occurrence, or if there were duplicates, get whatever the duplicate would be. Here we could say get the first occurrence or the last occurrence, or in our case, we want an exact match, and so we could specify 0 or nothing at all. If we specify nothing at all, it defaults to the exact match. And sure enough, we get a 2. If this was not 1010, but 1025, we get row 4 for Winfred here, okay? Now index will go to a specific row number, and then it will return back whatever column. So let's say we wanted to get the last name here. We do equals index. Okay. Now, what do we want to get? Well, in this particular case, I want you to go to the client's 434 table, and I want you to get the last name. This next bit for the row number, this is where you write the match function, and we'll do that next. But for the time being, I'm just going to hard code 2 in here. And we're going to go ahead and close our parentheses, and that goes ahead and gets Ronnie's name. And what this is doing, it's going to row 2. And it's going specifically to that last name. And as you can see here, we're kind of getting, we're telling it the X and Y. We're telling it how to match this stuff up. So now let's do index and match. We'll do equals match. Go grab the value B3. Go match this to the client's 434 table, the ID column. Okay, that gets you 2. I usually write the match function first, then I'll come over here and I'll write my index function. And I want you to go and get to the client's 434 table, get my last name, and then the row number, well, that comes from that match function. Like this, and that's how you can get it. Okay. So index and match is actually two different formulas. They're a compound formula. You got your match function, which goes and gets the row number of the record that you're looking for, and the index function, which will go to a specific row and get the column that you're looking for. All right, let's take a look at XLOOKUP. Now, XLOOKUP is the bee's knees, folks. It's the real deal. It combines the ease and use of index and match. I'm sorry, it combines the ease and use of VLOOKUP with the power of index and match. And it makes everything easier. Now, there are several functions as it relates to XLOOKUP. Sorry, there are several arguments as it relates to XLOOKUP. But there's really only three. What we're looking up, and what we'd like to get back, and then what type of match that we would like. Okay, it's pretty simple. So in this case, sorry, let me rephrase that. What we're looking up, where we're looking it up to, and then what data that we would like to get back. In this case, we're going to tilt to look up cell B3 here. And our data is clients 4. So that's the name of our table. And so we're going to say, hey, go run this lookup. Look up cell B3 here and go look it up to clients 4. Okay. And I'm going to tell it what column to look up that number. And I'm going to say, look it up specifically to the ID column. And then return back to me from clients 4. And I want, in this particular case, the first name. Okay. And so the syntax of this is really simple. The formula is XLOOKUP. What we're looking up, in this case, cell B3. Okay. Go look it up specifically to the clients 4 table and look specifically in the ID column. And I want you to get back from that same table the first name. And if I click this and we put our end parentheses here, we get Emilio as popped up. Now, what's really cool with XLOOKUP is that it can look up a couple of different ways. It can, and it can also do built-in error handling as well. So what if this is an invalid entry right here, right? We get QQQQ, you know, somebody puts in some bad data. Well, we would see that pop up, and we'd actually see that #NA anywhere here. If we had the same thing, okay, we'd see that #NA, and likewise over here, we'd see #NA. Well, that means just not applicable. Now, the way we've traditionally handled this is what? If error, right? We'd have to come over here in the front of our cell, and we'd wrap this, and we would do maybe 2 double quotes to make that error message go away. XLOOKUP, what's awesome with this is actually has built-in error handling. So we can say XLOOKUP, go look up cell B3, go look it up to the clients 43 or clients 4 table, the ID column, get me back clients 4, and get me the last name. And as the fourth argument here, we can do what if not found. Okay. So we can actually specify if there's an error, what to do. And so we could, for example, put in, instead of nothing here, we could do a double quote, not in list, and we can end it right there. And it's getting that #NA, we can get a nice error message. Same with before, we could put in a 0. We could also do 2 double quotes like this. And if it's not in the list, it will display nothing. Now, if it is in the list, 8559 here, it will return the value. Let's do 2 more of these real quick. XLOOKUP, go look this up. Clients 4 table. ID is our column. Clients 4. Let's get our title. Okay. And we're going to display nothing if there's an error message. Now, we've got two other optional arguments here: match mode and as well as search mode. Now, previously, we could either get with VLOOKUP, it's really an exact match or an approximate match, the biggest but not greater than, or the exact match. Here, we can either get an exact match, the biggest, or the smallest. So if there's duplicates in our list, we could say, you know what, get me the first one or get me the last one in that list as well. So that could be really useful. We can also put a wildcard in here as well. Now, by default, 9 times out of 10, you're going to want that exact match, but you could specify if there was duplicates, whether it should get the first item or the last item. And you could also specify how it should search. Now, previously, you could only search top to bottom. Now, if you wanted to, you could start at the bottom of your list and search up. Okay. Most people will not need this level of specificity, but it's there if you need it. Okay, we'll go lookup U here, and our lookup array will be our clients 4, our ID column. Go ahead and get back clients 4, and in this case we're going to get our company. Look how easy this is with tables. You don't have to remember the index number. You just specify using those open brackets what column you'd like. It's a no-brainer, folks. And we'll just say return nothing. And there you go. This is a great way where you could leverage tables and your different lookup formulas. Now, in practice, I personally end up using index and match more than anything because I need cross compatibility. But if you have XLOOKUP, your entire team has XLOOKUP, use XLOOKUP. You're going to find that to be a much better feature and function with respect to your calculations. Let's go ahead and take our afternoon break. And when we resume, we're going to go ahead and pick back up. And we're going to go ahead and talk about probably do one or two other things with respect to our formulas here. I'm going to show you some date arithmetic as well as some financial calculations. Then we're going to go ahead and take a look at Power Query, and then we're going to go ahead and take a look at pivot tables. All right, folks, it's been a great day so far. We've got one more section here. We're going to go ahead and look at those fields. Thank you so much for being here.
This concludes today's presentation. As a reminder, if you're watching or listening to our show on YouTube, Facebook, or elsewhere, you can earn credits by going to cpetoday.com and passing a brief 5-question quiz. If you're a new watcher or listener to our show and you'd like to earn a credit, you can do so for free by using coupon code ONEFREEPODCAST at checkout. You can make today's class or any other class of your choosing 100% free with this code. Please consider reaching out and connecting with us on social media. You can subscribe to our channel on YouTube. You can follow us on Twitter. You can like us on Facebook and more. Feel free to leave us a comment. Also, please consider subscribing to our show wherever you happen to receive your content, including Apple Podcasts, Spotify, Google Play, and others. Thank you so much for being here. We look forward to seeing you back in the office the next time around.